Yeah. So, where was I? Okay. So, what is this? The question says the following: what is the sequence generated by the generating function f of x equals 2x cube plus 3x to the 5 plus 4x to the 6 plus 5x to the 7 plus 6x to the 8 and so on. So, yeah, can you try your hand at this? So, look at the form of what a generating function should be like, and here what it is. Okay, Akanksha says D and Divya says D. Okay, let's see. Um, so, okay. So, the question says, what is the generating function? No, what is the sequence generated by the function? So, the given function is, yeah. So, the given function is f of x equals 2x cube plus 3x to the 5 plus 4x to the 6 plus 5x to the 7 plus 6x to the 8 and so on. Right. Now, let me write it in the standard form. Okay, the standard form should have all the degrees, all the powers to say. So what does that mean? I need something times x to the 0 plus something times x to the 1 plus something times x to the 2 something times x to the 3. Okay, but we already know 2 times x to the 3 is there plus x to the 4 we don't know. So for those points that we don't know, we'll put a 0 because it means the same thing, right? So these two are equal because we are multiplying by 0 means that particular degree term is not there. So plus 3x to the 5 plus 4x to the 6 plus 5x to the 7 plus 6x to the 8 and so on. Now we need to look at the coefficients and then form a sequence 0 followed by a 0 followed by a 0 then 2 0 3 4 5 6. Yeah, then good. Yeah. So the answer is D. Okay. So yeah, for those who joined just now, the question is, what is the sequence generated by this particular function, generating function? So I just write it in terms of all the terms with all possible powers like x to the 0, x to the 1, and so on. And as we know, the particular coefficient at the function will actually tell us what the sequence is. Okay, and so on. So that's it. So the answer is B. Right. So that was a simple question. Okay. Now, yeah, another nice question. Um, so yeah, what is the question? Oh, okay, okay. There's a mistake in the series. It seems should be 1 3 6 9 27. Oh, okay. 3. Okay, okay. No, it's fine. It's fine. Yeah. So yeah, can you tell what the answer is for this particular? 1 3 9 27 and so on. This is my series. So what is the pattern you see here? I mean, you have, in other words, you have 1 3 or 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3 and so on. So this is the pattern. So this is 3 to the 0. Okay. I think there's a problem in the options. Sorry, yeah, there's a problem in the options. So yeah, if please don't look at the options. Okay. Yeah, there's a problem in the options. But so I'll rather show it. So oh yeah, okay. Divya is correct. Yeah, that's right, Divya. Good. But I'm sorry for confusing others due to the options. So the answer does not figure out in the options. Well, the answer is actually 1 minus 3x. 1 by 1 minus 3x. Why? Previously we've said, okay, 1 by 1 minus x, okay, is equal to 1 plus x square plus x cube plus and so on. Right. Now we need, what do we need? We need 1 plus 3x plus 3x square plus 3, this is 4, x to the 3 square, 3 cube, sorry, 3 cube x cube, okay, and yeah, 3 cube x cube and 3 to the 4 x to the 4 and so on. This is what we wanted, right? Now we see that, if I take 1 by 1 minus 3x and treat this as my x now, then all I'll get is 1 plus x, 3x plus 3x whole square plus 3x whole cube plus and so on. Right. So this is what I get. But this and this is nothing but the same thing, right? So this is 1 plus 3x plus 9x plus 27x and so on. So the required answer is 1 minus 1 by 3x. 1 by 1 minus 3x. Or you can remember as a general fact, okay, that 1 by 1 minus ax, okay, will generate 1 plus ax plus a square x square plus a cube x cube and so on. You can also remember this as a fact. Otherwise, you can look at this particular observation. Okay. Yeah, I hope that is fine. But do let me know if you want to repeat it. Also, I'm sorry about the options. Should have double checked it. Okay. So the question says, what is the coefficient of x to the 5 and 1 minus x whole to the minus 10? Okay. So here we need like a general formula. So in the lectures, I will not mention how this is obtained, okay? In the lectures, we noticed the following, that coefficient at position r, okay, this is r, of function, what is my function? 1 minus x whole to the power minus n is equal to n plus r minus 1, choose r. Okay. So yeah, this is a very important formula which will apply a lot in the coming questions. The coefficient at position r of a function 1 minus x whole to the power minus n. Okay, remember this is minus n. I mean, or in other words, this is nothing but 1 by 1 minus x whole to the power n. The coefficient is given by n plus r minus 1, choose r. So now it is straightforward how to solve this question. So can you tell me what is the coefficient of x to the 5 and 1 minus x whole to the minus 10? So you can just apply the formula, and if you apply the formula correctly, you'll get the answer. Okay, what is this? 2000. Okay. That is correct, Gomati. The answer is 2002. Yeah, Akanksha. A is the correct answer. So, I mean, just straightforward application. R is 5 here, and n is 10 here. Remember, not minus 10 according to the formula. And what you do is simply n plus r minus 1, choose r. Correct. So what you get now is n is 10 plus r is 5 minus 1, choose r is again 5, which is nothing but 14, choose 5. Now you can simply do like 14, 14 minus 5 is 9, right? 14, 13, 12, 11, 10 by 5 factor 5, 4, 3, 2, 1, and this thing will be 12, and 10 will go, right? Now all I get is 14 times 13 times 11, right? So okay, where's the calculator? Fourteen times 12 times 11. Oh, okay. Did I make a mistake? Oh, 14 times 13 times 11. 14 times 13 times 11 is 2002. Right? Yeah, good. So the answer is 2002. So why are we even interested in this? Like, because this particular quantity 1 minus x to the power minus n, this occurs a lot. Okay, as we'll see in the later questions, in the coming questions. So we'll be using this fact a lot. So let's try this particular question. Okay, so there is a certain trick how to do this, and this trick does not work always. Okay, but the question is very similar. Okay, the question is very similar again this time. The question says, what is the coefficient of 14 in x to the power 4 plus x to the power 5 plus x to the power 6 plus x to the power 7? Now one might say, oh, okay, so you know, r is 14, but this 3 is not of this minus 3 form. Okay, and also it is not just minus 3, it should be 1 minus x to the power minus 3, right? So what is the coefficient of x to the 14 and x to the this particular function? That is the question, and let me call this f of x. Okay, now what I'll do is the following. F of x is equal to, okay, this is an important technique, this was already also done in the lectures I believe, but still, x to the 5 plus x to the 6 plus x to the 7 whole cube. Okay, now what you do is take x to the 4 common. X to the 4, okay, common, and then you have 1 plus x square plus x cube plus x to the 4. Okay. Now you see that we are going, this is similar to a generating function. Okay. But let's bring the 3 inside, this cube inside. And 3 times 4 is 12. And 1 plus x square plus x cube plus x to the 4. Okay, good. Now what we are demanding is, okay, need coefficient of x to the 14, right? But x to the 12 is already common from here. Any coefficient that will come will be here, will be contributing by this guy. And this, how will we, what will happen is this x to the 12 will actually multiply with the term with the coefficient x to the 2, okay, to give us x to the 12 plus 2, which is equal to x to the 14. Gomati says 1 plus x square times 4 to the power 4, you mean. Wait, let me see again. Gomati says 1 plus x square plus x cube times 4. Times 4, okay. To the power 4, you mean? But it's to the power 3. The question was originally for to the power 3. Okay. Do let me know what if you meant to the power 3. I think that is correct, right? Oh, okay. Sorry. Yeah,
So
good.
in second line, you
Right. Sorry. This 3 should go here, you mean, right? You mean this was missing, no?
above line, sir. Sir, we take it x power 4 is common.
Right.
Then 1 plus x squared plus x cubed.
Oh, right. Sorry. I don't know what is happening to it. Okay. Yeah. Sorry, we took x to the power 4 common. That's right. Good. So we have x square, x cube. Oh, okay. That's why you meant the 4. Okay. X to the 4 you meant. I thought it was times 4. Okay. My bad. So, yeah. Again, there's a problem here. X square, x cube. Right. Yeah. Good. Thanks. So, yeah, this particular x to the 12 will actually multiply with an x square in this particular term to give us x to the power 12 plus 2, which will give us x to the 14. So, in other words, if we need the coefficient of x to the 14, what we actually mean is we need coefficient of x to the 2. Okay. So, in this term 1 plus x square plus x cube whole to the 3. This is what we want. Now what we'll do is this particular, we don't know a generating function for this. I mean, right off the bat we do not know, but we know the generating function for something similar, and that is this particular generating function 1 minus x. This is nothing but 1 plus x square plus x cube, but it does not stop there, it keeps going on. So what I'll do is I'll write it as 1 by 1 minus x. Okay, and this will work. Why? Because the first few terms of this the sequence that it generates will be same as this, but mind you, it will not always work, and there are examples later on where it will not work. Okay, but anyways, this is substituted by this particular generating function. Now this is nothing but 1 minus x whole to the minus 3. Okay, so we've now reduced the problem to be as follows: coefficient of x square in 1 minus x whole to the minus 3. So coefficient of, it is similar to this question now. So now can you tell me, after simplifying, what the answer becomes? Coefficient of x square in 1 minus x whole to the power minus 3. It comes as a 6. Right. Good. So now we can directly use the formula. What is the formula? N plus r minus 1, choose r. What is n here? N is 3 here and r is 2 here. So this means we need n plus 2 minus 1 divided, choose 2, which is 3 plus 2 is 5 minus 1 is 4, choose 2, which is equal to 4 times 3 by 2 factorial, which is 2. So 2 times 2 is 4, which is equal to 6. So the answer is D. Right. So that was my answer. Yeah. So I hope that is fine. So the answer is D. Okay. So the general idea is just we took x to the 4 common, and then we got this, similar to the standard generating function. And then we substituted the standard generating function, and then we applied the formula and got the coefficient of x square. And we'll be using this kind of logic a lot. Okay. And before I use it on some kind of counting question, okay, I'll first write how we can combine the things. Okay, so counting with polynomials. So this is one way to illustrate this problem. Okay, the question says the following: in how many ways can one form a 4-letter word from the following smaller blocks if one were to choose one block per line in the construction of the word? Okay, and a similar one was done in the lectures also. So what it means is, example of a word here is I choose one from the first line, let's say RA. I choose another from the second line, let's say I choose C. Okay, and I choose one from the third line, E. So RAC, race, is one word. Similarly, PACE is another word. I chose this from the first line. And similarly, A and D is another word. I chose this, this, and this. So the idea is, so the question is, how many 4-letter word from the following smaller blocks? So I should choose something like this, but not this. Now, how do I achieve that? Well, one way to do it is by using polynomials. Okay. How do we use polynomials? We take the count to be corresponding to coefficients. Okay, in this case, that's it. Coefficients. Okay. We choose the count to be corresponding to coefficients, and I'll show, okay, that the length corresponds to the power of a term. How? I write the polynomial as follows. Okay. So from the first line, you can choose a 2-letter word, and a single letter word. So 2-letter word, I'll denote by x square. 1-letter word, I'll denote by x to the power 1. And similarly, if it's a 3-letter word, x to the 3, and so on. and so on, and 3-letter word is x cube and so on. Okay, so this is what I did. Now what I'll do is, let me look at the first line from which I need to pick. I can pick a 2-letter word, I can pick a 2-letter word, and I pick a 1-letter word. So what I'll do is, I can pick a 2-letter word. X square is what I am using to denote a 2-letter word, mind you. I can use a 2-letter word or a 1-letter word times, okay, the second line, NCLO, a 1-letter word, C is a 1-letter word, and LO is a 2-letter word, times ET, so 1-letter word plus a 1-letter word. Okay, so this is what I have in hand now. Now what I'm doing is, I'm telling you this, that okay, so let me further simplify. 2x square plus x times 2x plus x square times 2x. Okay, so this is what I have. Now remember that the powers will add. So this is, if I choose 2x to multiply 2x square to multiply with 2x, okay, I'm saying that I'm choosing a 2-letter word, then a 1-letter word. Okay, and if I choose a 2-letter word and a 1-letter word, since their powers add up, it will give x cube. And similarly, what I have in hand is a 2-letter word plus a 1-letter word, which is a 3-letter word. So it exactly corresponds to that. Okay, so you can think about it more deeper in the way, okay, why the coefficients represent the count. But finally, by the intuitive logic I have, that I need coefficient of x to the 4. Why? Because I'm looking for the number of 4-letter words. Because I know that the coefficient of x to the 4, because x to the 4 represents 4-letter words, the coefficient of x to the 4 actually represents how many 4-letter words I can form by multiplying this multiplication. And this multiplication here is like combining in terms of strings, concatenation in terms of strings. So I need to find the coefficient of x to the 4. So now you can just simply do a normal expansion and then find what the coefficient of x to the 4 is. So yeah, I'll give you a few minutes if you want to try. So tell me what the coefficient of x to the 4 is in this particular polynomial. Yeah. Okay, that's quick. What function is 10? Okay, yeah. So it's just, yeah, the answer is 10, Akansha. It's just simple multiplication here. Okay, what you do is, so you have 2x square plus x times 2x plus x square times 2x. Okay, now let me multiply. Komati, yeah, good, 10. So 4x cube plus 2x to the 4 plus, now I'll multiply these two. X times 2x is 2x square plus x times x cube, x square is x cube times 2 of x. So yeah, so then 2 4s are 8, x to the 4 plus 2 2s are 4, x to the 5 plus 2 to the 4 x to the cube x to the 3 plus 2x to the 4. Okay, I made a mistake somewhere. Okay, anyway, x to the 4 will be, yeah, no, it's not a mistake. So these two will add up, and then you have x 10x to the 4 plus 4x to the 5 plus 4x to the 3. And therefore, the number of 4-letter words I can create is given by the coefficient of x to the 4. And our answer is 10. Good. Yeah. So 10 is B. Option B. So yeah, I hope that was clear. Okay, this was an important concept. Okay, and representing choices in terms of polynomials. So choices. This now the first line, second line, third line. Similarly, if we need to like choose between different rounds and choose between different people and so on, we represent it instead of lines. We'll have people or something. But the idea is now what we'll do is we'll combine the ideas of generating functions with the idea here, okay, of these words, counting words. Now, yeah, this particular question exactly combines them. Okay, the question says the following: what are the number of ways 10 votes can be distributed among 4 candidates? So, something similar was done in the lectures. So, if you already know, then good, give a hand at it. If you don't, then I'll explain. But still, please try to combine the two techniques used before. The general idea is I need to create a polynomial and then try to find a particular coefficient of that polynomial. I mean, there are more than one way to do it, but using generating functions, any idea how we can do it? Conscious is B. Okay. Okay, let's see. I'll give a few more time. Okay, then I'll solve it. So the question says, what are the number of ways in which 10 votes can be distributed among 4 candidates? Okay. So, okay. Number of ways 10 votes can be distributed among 4 candidates. Now, I mean, there are quite a few methods to do it. One popular method is that, the bars method or stars and bars method. If you remember from this past, lectures, then you can have 10 stars, and then how many ways can you place these, bars to, separate, categorize this to the candidate 1, candidate 2, and so on. So how many ways can you do it? That is one way to do it, but we can use polynomials to do it. So first, let's look at the previous problem about choosing these words. So each of these places showed the choices for the first line, then the next multiplicand showed the choice for the second line, and then the third line. Okay, similarly we'll do the similar thing. So well, the first candidate can get 0 votes, which is represented by x to the 0, or he can get 1 vote, or he can get 2 vote, or he can get 3 vote, 4, and so on until he gets 10 votes, not more than that. Okay, and what about the next guy? Next guy is shown by a multiplication, x to the 0 plus x to the 1, and so on till x to the 10. And there are 4 people here. So times x to the 0 plus, this is for the third candidate. Even for him, he can have 0 votes something until 10. The next person can also have x to the 0 plus x to the 1 plus x to the so on till x to the 10. Right? This is nothing but x to the 0 plus x to the 1 plus and so on till x to the 10 whole to the power 4. I'm multiplying these blocks 4 times. Right? So now the total number of votes is 10. Right? So if the total number of votes goes to like 11, 12 and so on, then that is all invalid because something is wrong with the distribution. But if the total number of votes is 10, right, then the distribution is proper. Let's say let's say this distribution, first candidate got 2, 2 and 3 and 3, and total is 10. So this is fine. This and such kind of distribution is represented by x square multiplied with x square multiplied by x cube times x cube. Okay, x square from here, x square from here, x cube from here, x cube from here. This is how this particular extent came. And different distribution will add to the coefficient of, and this plus, let's say, x1 plus x cube times x cube times x cube times x cube. Now this is also x to the 10. So together they'll contribute 2x to the 10. So you see, I hope you see that, different choices of powers, okay, among these different choices of, literals among these places, okay. If I choose x square here, x square here, x cube here, x cube here, or I choose, x1, x to the 1 here, x cube, x cube here, these will contribute to the coefficient this way. So the coefficients will exactly represent the number of choices you have in distributing the votes. And we are only interested in x to the 10 because, x to the 10, on totaling it to 10, it shows that, the distribution is correct. If it was x to the 11, let's say, then that would not be correct because someone is getting more votes, but, total votes were only 10. The question says 10 votes. How will you distribute 10 votes among 4 candidates? So I hope you see the connection. Okay. So, so my answer is, okay, coefficient of x to the 10 in the polynomial x0 plus x1 plus x and so on till x to the power 4. This is my answer. Well, something that works because it is of a nice form is the previous trick. What is the previous trick? We substituted this with 1 by 1 minus x, if you remember, because 1 by 1 minus x, or in other words 1 minus x, okay, to the power minus 1 is nothing but 1 x plus x square plus x cube and so on. And since the generating function looks the same, appears same until the first few terms, I'm substituting with 1 minus 1 to the power x whole to the power 4. Okay, good. Now find coefficient of x to the 10. Okay, so how do you find coefficient of x to 10? Now we go to the previous formula that we saw. Okay, so what is the previous formula? The formula is coefficient at position r of a function 1 minus x whole to the power minus n, okay, or 1 by 1 minus x whole to the power n, is nothing but n plus r minus 1, choose r. N plus r minus 1, choose r. So similarly, we need to find coefficient of x to the 10. So r is 10 here, and this is x to the minus 4, right? So n is 4. So the answer is n plus r minus 1, choose r, which is 4 plus 10 minus 1, choose 10, which is nothing but 13, choose 10. Now you can leave it at this, or you can simplify. So if you want to simplify, you get 13 times 11, 12 times 11, okay, divided by 3 factorial. 3 factorial is nothing but 6. 6 times 2 is 12. So 13 times 2 is 26 times 11. So what is 26 times 11? 286. So my answer is 286. 286 is B. Okay. I think someone, yeah, Akash had answered it. Good. So B is the answer. So please let me know if there is any problem. Okay, there are any doubts about this particular process. I mean, this is a slightly more advanced way of counting. So do let me know if there is some hiccups. Okay. Well, the key thing is just multiply. So we highlight the choices by these polynomials, and then we just find the correct coefficient. Okay. I'll show another one. Okay, I think we might end early today. So I'll show another one. The question says, what are the number of ways 10 votes can be distributed among 4 children if each candidate must receive at least 2 votes? Okay. So how do you do this? Again, the question is same. The question is very similar, except this at least 2 votes. So before, what did we do? We did, the candidate can take 0 votes, 1 vote, 2 vote, 3 vote, 4 vote, and so on. But this time, remember, these 2 guys will not occur. These 2 guys will not occur. So this time, my polynomial is any politician can get 2 vote, 3 vote, and so on till 10 votes. Another politician will also get the same. Another person also has the same chances, and the other one. So I have x square plus x cube plus x to the 4 plus and so on till x to the 10. So yeah, we've encountered this situation earlier. This is not capturing any generating function that we've already seen. But how do I go about this? How do I further bring it into generating function form? Okay, and there should be a to the power 4. Well, the answer is that you just take x square common. Okay. Take x square common. Then you have 1 plus x square here, plus and so on till x to the 8 whole to the 4. Now, what do you want? Now we just multiply it inside. X to the 8 times 1 plus x square plus x to the 8 to the power 4. Right? Next, see, what we needed was coefficient of x to the 10 in this polynomial. But we've discussed it before. Since x to the 8 is already here, we just need the coefficient of x to the 10 minus 8, right? Which is need coefficient of x to the 2, 10 minus 8. Because it will eventually multiply with this x to the 8 to give x to the 10. So, coefficient of x to the 2 in this 1 plus x plus 1 x to the 8 whole to the 4. So can someone calculate and tell? Because this is nothing but 1 minus x whole to the power minus 4. This is not exactly equal, but we are assuming it to be equal like before. Okay, yeah, this is 10. I'm not sure what the answer of this one. I think it is correct. I think it is correct. I'll give some more time. Okay. Well, we have the formula, right? Here n is equal to 4 and r is equal to 2. So what is the formula to find the coefficient of x squared? We just do an n plus r minus 1 choose r, which is nothing but 4 plus 2 minus 1 choose 2, which is equal to 5 choose 2. And what is 5 choose 2? 5 choose 2 is nothing but 5 times 4 times 3 is cancelled out times 2 factorial, which is nothing but 2, and 2 times 2 is 4, and 5 times 2 is nothing but 10. So the answer is A. Yeah, good, Gomati. The answer is A. Right. So yeah, I hope the answer, the procedure is clear. Key things to remember is that, if it is not in the generating function form, I can force it to be in the generating function form by just taking common, and I'll be all right. And yeah, another thing is that if, since x to the 8 is here, I need to find the coefficient of x to the 10. I'll just look for the coefficient of x square here. Okay, and then I'm done. So yeah, we'll solve a few more problems of the similar flavor. Okay. So here I'll tell you not to look for the final answer, the final coefficient you get, because doing that is slightly more complicated in these questions. So try these and just let me know what is the coefficient that we are looking for and in which polynomial. What is the coefficient in which polynomial? Try to figure that out. You don't need to look for the actual coefficient because the same previous techniques will not work. I mean, the final technique will not work. The direct formula. Yeah, that's right. I mean, solving those kind of um, answers would come in later lectures. Those kind of questions. So the question is, what are the number of ways in which 12 action figures can be given to 5 children so that each child receives at most 3 action figures? 5 children, each child receives at most 3 action figures. So, and total are 12 action figures. So just tell me what coefficient in which polynomial.
Sir, coefficient of x power 12 in 1 plus x square plus x cube to the power 5.
Okay, coefficient of x to the power 12 in 1 plus
1
x plus x square till
x cube
okay till x cube
power 5 whole power 5.
whole power 5. Okay. Oh, okay. At most, right? Yeah, that's correct. That's correct. I was thinking at least. Okay, good. Yeah, so this is the correct answer. I'll explain why. Well, again, the choices we represent by these powers, right? So the first child gets, 0 action figures, and or 1 action figure, or 1 action figure, or 2 action figure, or 3 action figure, but not more than that, because they say every child gets at most 3 action figures. And again, you can do, x naught plus x to the 1 plus x square and so on, but it's same for all the children, right? So the constraints are same for each child. So how many children are there? 5 children, so I can just do to the power 5. And what is the total number of action figures? Number of action figures is equal to 12. So need coefficient of x power 12 in the polynomial. Which polynomial? This polynomial. X to the power 0 is nothing but 1 plus x square plus x cube whole power 5. And this is your answer. Good, yeah. So I hope that is clear. So, I mean, the remaining questions are also playing around with these kind of answers. And yeah, that's right, yeah. Yeah, okay, good. So yeah, let's move on to the next question. So here too, can you tell me what is the coefficient, what is the polynomial? In how many ways can 25 donuts be distributed to 4 police officers so that each officer gets at least 3 but not more than 7 donuts? Okay, now we have some more restrictions. How do we highlight them? So it's not very difficult, it's not very different from what we've just seen. Just let me know what are the coefficients, coefficient and the polynomial.
So coefficient of x power 25 in x cube plus x4 plus x5 plus x power 6 plus x power 7 whole to the power 4.
X power 6, x power 7 whole to the power 4. Yeah, good. Yeah, that's correct. Well, again, the logic is similar. They are saying each police officer gets at least 3 but not more than 7. So the number of donuts that are received by each police officer ranges from 3 to 7. So the first person gets, it cannot be that the first person gets 0 or 1. It will only start from 3. At least 3 donuts, 4 donuts, 5, 6, 7 donuts. And this is true for all police officers. So I'll multiply this with itself 4 times, which means it is to the power 4, right? And what am I looking for? I'm looking for coefficient of x to the 25. Or I mean, some of you may also think of simplifying it this way, that you can take x to the 3 common, and you can do 1 plus x square plus x cube plus x to the 4 whole to the power 4. And since x to the 3 is already there, and this will become x to the 12 times 1 plus, so until x to the 4 whole to the power 4. So you might say coefficient of x to the 13 in this particular polynomial, and that too is correct. But unfortunately, we're going to use the previous technique. But I mean, you have more advanced way of looking for these kind of coefficients. Okay, we might see them later in the course. Okay, or what you can do is, you can verify them using these online polynomial expanders. So there are expansions possible where you can just have online websites where you put your polynomial and they'll expand it for you. They'll give you the coefficients. You can verify them this way, and this is quite interesting. How you can find the count using coefficients. Yeah, well, that's that. Yeah, and that was the answer. Quotient of x to the 25 here. Now I have a final question. Seems we are ending pretty early today. So yeah, I've run out of questions. So yeah, this is the final question. So please attempt it. Similar technique, just slightly different. I think yeah. In how many ways can you choose a dozen dosas from three varieties, plain, masala, and onion, if at least two dosas of each kind, but not more than three onion dosas are chosen? Okay, I mean, there's a lot of play of words here, but once you figure it out, it is pretty straightforward. So please try.
So coefficient of x power 12 in x square plus x cube whole into x square plus x cube plus x power 4 plus so on x power 12 whole power square.
Yeah, seems correct. Good. uh, yeah, looks correct. Yeah, good. So again, the flavor is very simple. So a dozen means 12. Okay, so there are 12 dosas in total. So you can already see that we need to find the coefficient of x to the 12 in the polynomial. And there are three varieties. Okay, so you know that there are three blocks that we need to multiply, right? And they are saying if at least two dosas of each kind are needed. Okay, they are saying at least two dosas of each kind are needed. So let's look at plain dosa. Okay, so two dosas, at least two dosas. So I'll start my numbering from x to the 2. Okay, and then next to the 3, and then next to the 4, x to the 5, and so on till x to the 12. So this means this is how many plain dosas I've chosen. Next, what I'll do, I'll go for masala dosa. Again, at least two dosas plus x cube plus x to the 4 plus so on till x to the 12. Okay, all well and good. And now onion. This is my choice for onion dosa. If I have to choose onion dosa, I cannot go till all the way till 12. I cannot choose 12 onion dosas. I cannot choose 11 onion dosas. Why? Because they are saying no more than 3 onion dosas are chosen. So I cannot even choose a 0 or 1 onion dosa because two dosas of each kind need to be chosen. So 2 onion dosa or 3 onion dosa are chosen. Okay, good. Now what we do is you simply multiply them, x square plus x cube and x square plus x cube plus and so on till x to the 12 square. This is the final polynomial I receive, and the total number of dosas I have in my hand are 12, right? And I need to find the distribution such that the total is 12. We mentioned that earlier. So number of ways is nothing but coefficient of x to the 12 in this particular, let's call it f of x. F of x. Okay. So yeah, let me know if there's any problem here. So yeah, is everything fine? I hope it's fine. So actually, one person joined just now, Omdipan. Oh, okay. We've come to the end of the session actually. So well, I have nothing more to discuss. I've ran out of questions. I think somehow this session ended very quickly. But well, just quickly generating functions. Okay. Okay, I'll just conclude it. Generating functions. Okay. Are used to generate sequences. That is one application. But another good aspect that we saw of generating functions is to do counting. And these distributions, for example, one question out here, the candidate question. Number of waste 10 votes can be distributed among 4 candidates. This could have been done by the star and bar methods. So how many sticks do you need? You know, there are 4 candidates, you just need 3 sticks. And how many stars do you need? You have 10 votes in total. And then you can use, 10 plus 3 minus 1, choose 9 or 3, whatever. And then you'll get your answer. But of course, if I have something like this, receive at least 2 votes, then I cannot use this technique. So I hope you appreciate the application of generating functions. Okay. So it is widely in use for, and later you might see some things like recurrence relations and all, where you'll use the idea of counting using functions. But yeah, to conclude, that is it. So if you have any more questions, just let me know. And if you don't, then you are free to leave. Okay. Okay. Yeah. Thank you, Divya. Gomati, Kiran, do you have any more questions? Oh, okay. Thank you, Gomati. Bye. Okay, Kiran. Yeah, good. Thank you. Bye.